Good morning and Jai Shri Krishna. Students, we are going to start the physics portion. So today we are going to see chapter number 12, electricity. I am Harsh Mehta. I am taking your science standard 10th, and today we will start chapter number 12, electricity. Students, we know that we mainly depend on our regular work to electricity. Why? Mobile that we use, laptop for work, or any electrical device which we use requires electricity. So how does this electricity is conducted through a conductor? This is what's our today's topic. So we are going to see how electricity is conducted inside a conductor. What is the main phenomenon which is working behind this concept? Okay, so chapter number 12, electricity. Students, you can see a schematic diagram in which I have taken a conductor. The conductor length is L, for example, and the area of conductor is A. So any conductor we have taken, mainly conductors are those who allow electricity to pass through them. So they are known as conductors, and the property they belong is conductivity. So normally metals we use as conductors because they are good conductors of electricity. Here, for example, you can take a copper wire. So metallic copper wire is taken, and I have connected this wires two ends with the help of a battery. I have connected a plug key and I have connected an emitter. Now what is this emitter? This emitter is nothing but how much electric current is passing through the circuit. It will be measured by this device, which we will discuss further. Plug key, as you all know, it is type of a switch. If it is turned closed, then only the electric current will flow. Battery containing positive and negative terminals. The cell which you have contains 1.5 volt. Here we have taken a battery, so it is around 6 volts battery. So that is what we have used over here. So when we connect the positive terminal of a battery to a conducting wire, then in return it is connected with an emitter, a plug key, and the negative terminal of the battery. So this is your schematic diagram. This schematic diagram is known as electric circuit. So according to your textbook, what is electric circuit? A continuous and closed path of an electric current is called electric circuit. So you can see the current is flowing in this direction from positive to negative. So I represented it current, electric current, as symbol I. What is electric current? So the definition is, if a net charge Q flows across any cross-section area A of a conductor in time t, then electric current is defined as I is equals to Q by D. You can see Q is the charge over here. The amount of charge is passing through the conductor. So that is charge. And time is taken for how much amount of time that charge is passing. So the ratio of charge and time will give us electric current. I is equals to Q by D. So conventionally, the direction of electric current is taken from positive terminal of the battery to the negative terminal of the battery. Now if I want to find how much electric current is flowing inside through this circuit, for that I have used the device called emitter. Remember students, emitter is always connected in series with the circuit. So it is always connected in series with the circuit. So here emitter I have taken, which will measure the electric current. Now you will say the mass we calculate is termed as in kg, the unit is kg. Then what is the SI unit of electric current? The SI unit of electric current is ampere. Or by symbol you can say A. Scientist named Andrew Mary Ampere, he founded this symbol. So on his name we have given this unit, SI unit, ampere, for electric current. So in the introductory page of your chapter number 12 of your textbook, they have described what is electric circuit, what are the different components of the circuit, and what are the different electric circuit diagrams that we have taken over here. Done? So in electric circuit we are describing this thing. Okay. So we were discussing about electric current. The SI unit of electric current is ampere. See, remember students, charge Q is denoted by coulomb and time is always measured in seconds. So ampere is also known as coulomb per second. Coulomb per second. But SI unit is used, so we will always write electric currents unit as ampere. But coulomb per second is also one of the unit inside your given chapter. Okay, continuing further, you know that if I want to define 1 ampere, what is 1 ampere? So I define 1 ampere as when 1 coulomb of charge is passing through a conductor in 1 second, then it is known as 1 ampere. So if I define 1 ampere, if the amount of charge passing through a conductor is 1 coulomb in time interval 1 second, then that is known as 1 ampere electric current. So this is your 1 ampere definition. Similarly, I have already discussed that you can measure the electric current inside a given circuit with the help of an emitter. So emitter is also used. Students, in some numericals you will also find some small units of electric current. For example, 1 microampere. 1 microampere is nothing but 10 raised to minus 6 ampere, and 1 milliampere means 10 raised to minus 3 ampere. So students, these are also some small units of electric current. 10 raised to minus 6, that is microampere, and 10 raised to minus 3, that is milliampere. Now students, you know the electric charge of electron is 1.6 into 10 raised to minus 19 coulomb. It is generally derived that it is the electric charge of electron, that is 1.6 into 10 raised to minus 19. Now, how this electric current flows, that I am going to discuss with you. Students, we know when we give an external electric force with the help of a battery, the battery contains positive and negative charges. This positive charge will tend to attract all the electrons inside the conductor. We know that electrons are moving in random directions. So these electrons, due to the positive terminal, that is the opposite terminal, will all get aligned in one single direction and will come and accumulate over here. And that is why it will flow the electrons. So due to this flow of electrons, electric current is generated inside the conductor. So this is your normal exhibition of electric circuit, in which they have explained that electrons are always flowing in the opposite direction of the electric current. You can see electrons are flowing in this direction while the current is flowing in the opposite direction. So it is always remembered that the direction of electric current is always opposite to the direction of flowing of electrons. So conventionally, electric current always flows from the positive terminal of the battery towards the negative terminal. So remember this. This is also an important concept to understand the electric current. So I have completed your introductory page of chapter number 12 from your textbook. Please refer the textbook and underline the definition terms. I have already discussed electric circuit, electric current, the unit of electric current, then the SI unit, then different small units of electric current, that is microampere, milliampere, and how does the current flow through a circuit. So I have also drawn the circuit diagram. You can also undertake a bulb. If you take a bulb over here, and if you find that the bulb is glowing, that means conduction is undertaken inside this circuit. So you can also take a bulb and see whether the given circuit is working or not. Thank you.